morning. His Excellency Dr. Ahmed Yamani, Rector of Princeton University, His Excellency Professor Saada Kuwaita, Vice Rector of Administrative Affairs, respected deans, chairmen, colleagues, honorable guests, and audience, ladies and gentlemen, good evening and welcome. PSU, as a leading private non-profit university in the kingdom, is keen to contribute in knowledge diffusion. One of its main objectives is to disseminate knowledge and recent innovations in science and technology through the organization of events like this one. And this evening, we are pleased to have a very interesting talk on robotics given by one of the worldwide leaders in the domain. In fact, robotics is a part of our everyday life. Most of our products that we are consuming are made, most of them by robot or half of them by robot. Even in our house, we have these home appliances which are in fact robots. They don't have exactly the shape of human, but in fact they are robots. The robotic field is multidisciplinary domain, from artificial intelligence, computer science, computer engineering, mechanical engineering, and even electronics, and a lot of domain, in fact, which make the area very challenging, and which make creation of the robot very challenging. In fact, it's extremely challenging to make robot that imitate human, or robot that is fully autonomous. This is why robot creator try to make a robot that do specific tasks, and hopefully later on they can succeed in making robot that fully imitate human, which is very extremely challenging task. Furthermore, Japan is worldwide leader in the robotic and is the biggest robot market worldwide. In fact, Japan is the most automated robot country in the world with a very high robot density. Robot density, in fact, it's a number of robots compared to manufacturer worker. In fact, Japan is by far the country where the robots are used in a lot of industry, mainly industry. Today, we are pleased to have Professor Tomotaka Takahashi from Japan. He's a robot creator. He's also CEO of a company named ROBO Garage that makes robots. And he is also a prominent researcher in the robotic field. Professor Tomotaka Takahashi he won several prizes in the robotic competition and in fact in international robotic competitions. On behalf of Dr. Ahmed Yamani, the Rector of Princeton University, we present you Professor Tomotaka to talk about the creation of new robot era. Thank you.
Good afternoon, ladies and gentlemen. My name is Tomotaka Takahashi. I'm from Japan. Now I have my company in Kyoto, and also I have my WG in Tokyo. And right now Japan is freezing cold, and when I come to this country, actually this is my very first visit. And I really feel happy to have this, nice weather and nice people. And I want to say thank you to people preparing such exciting moment. Today, I'm going to talk about a robot, the creation of a new robot era. The reason why I choose this title is because through the developing robot, we can create new lifestyle, the new era living with robot. And there are a lot of expectation to the robot, but there's a lot of misunderstanding is going on to the robot. First of all, a lot of people is thinking about home robot the humanoid robot working for you, and some people think, humanoid robot washing dishes or cleaning floors using vacuum cleaner. But actually, it's not going to happen. They're not doing these kind of tasks as good as your mom. Because humanoid robot will have different tasks. Before going to the main topic, I have to talk about the background about the present situation. We need interface revolution because, as you know, a lot of electric appliances or cell phones, smartphones, these gadgets are getting too complicated. There's too many functions. And we are tired of reading thick manuals, and we are tired of struggling. There's too many buttons on the remote controllers. And that's why people choose, for example, iPhone. iPhone has just one button on the surface and the other one on the top. It's so simple. And there's no manual book with iPhone because people can, use iPhone just following our instinct. And also, there's another example. Nintendo. Nintendo games have, like, for example, motion sensors in the controller, and then you can swing the controller. You can play tennis video game or golf, or these kind of games without pressing so many buttons. But actually, these things, the iPhone, for example, iPhone camera is not as good as Japanese cell phone, but people choose iPhone. Like, for example, Sony PlayStation 3 is much better than Nintendo as a computer, but we choose Nintendo. So people tend to choose something which has better interface design. And one of the latest technology of interface design is voice recognition. And our iPhone have voice recognition, and you can talk to your smartphone, and the smartphone will move according to your voice. But actually, we don't use that often because we are kind of hesitate to talk to such square box. And but you can talk to your pet, like pet fishy, pet turtle, or even like a teddy bear sometimes. So what I want to say is to realize communicating, right? To realize communication, the intelligence of the opponent is not important. The important thing is how we feel to the object. If we feel some kind of knife to the object, then we are happy to talk to them. And also there's another topic, knife logging. We use, for example, Google or Amazon, these kind of IT services every day, and these services are based on behavioral targeting, and it's they record your past action, past behavior on the internet, and so when you buy something, they'll send you something related to your past product. So they send a lot of useful information, even according to your past behavior. So, but unfortunately, they can gather your information only when you are on the internet. And probably we are connecting to the internet probably less than 3 hours a day. The other, 20 hours, Google or Amazon, they cannot gather your useful information. So that's why Google recently invented Google Glass. Google Glass has camera on your glasses and to record what you see, what you watch, and then they'll send the information of the restaurant or information of the product, this kind of information. But even the Google Glass cannot record what you think in your mind. And I think humanoid robot can help these problems. And today, I have robot, and it can be a help to imagine the idea of the future. And actually, robot is in my bag here. This is a special bag designed by me for the robot. And today, I'm not here to demonstrate my bag. So instead of that, I'll start a demo of my robot. And this robot has several features. One is he can move he can walk more naturally. And the other feature is he has special patented technology in his legs, and so that's why he can jump or run and turn around. Now I'll show you on the table over there. This is a robot named ROBO, and since he's quite small, so we have camera, and you can see on the screen. And I'll turn him on. So he has voice recognition, and I'll talk to him. こんにちは。こんにちは。And he can understand some English words, so I'll ask him his name in English. What's your name? Robot. His name is Robot. As I mentioned, his legs is linked by belts, and that's why he can move fast action like jumping or running. Now I'll show you. 開始. Also, he can run. But you can somehow, see the image of robot for communication. It's not such creepy to, me talk to a robot. It seems kind of natural. And that's what I think that's what I need for humanoid robot. Now I'll go back to my presentation. So we treat robot. We know a robot is not actually living. It's made of plastic and carbon fiber and metals and motors and battery, but we can treat them just like a living thing. And then we can talk to them. And that's the first machine through our history. No machine can talk to us, or interact with us. And then the robot, humanoid robot, will be the first, and it can be an ultimate interface for us. And so future life will be like this: small humanoid robot, and for example, I talk to Robot, and like a talking about kind of daily thing. It's just talking stupid thing. And then he can gather all the information about my lifestyle, my preference, and then, for example, he can record my favorite soccer team game on TV, or he can send information about the new personal computer is on the market from Sony, or he can control home security system, and also he can control other practical robots like a vacuum cleaning robot. So human-shaped robot do not do house chores, but instead of him, he controls other robots, and other robots and other electric appliances do physical tasks. And also, I believe we will talk to somebody through the robot. So somebody controls my robot, I talk to my robot. It's like an avatar on the internet. So robot will be some kind of translator between human being and machine, or between human being and the internet, or human being and another human. And to do that, robots should be well designed. I mean, the outer shape is important. If robot is not cool, or if robot is not cute, then we hate them, or we feel we are scared, and we might have some kind of negative feeling. So that's why appearance, outer shape design is so important for humanoid robot. Also, motion should be smooth, and communication itself is also important. And also, the size itself is important design. I believe the robots should be smaller. I mean, the robot is still too big for me. Humanoid robots should be just as small as your smartphone, and put into your pocket, and you talk to a small human robot every day, and that's a really important point. And they don't, since they don't do any physical tasks, they don't need power, they don't need speed to, move to somewhere far, because you can carry it with you. And then if robot is big, there are several problems. Actually, there's two problems. One is it's harder to keep it safe. If the robot is as big as human being, if he falls down, someone might get hurt or injured by robot, and it's not acceptable. Especially the robot has human shape. Human-shaped machine, if in the worst case kills somebody, it's not acceptable in our society. And another problem is if robot is big, then robot looks kind of dumber, you know. It happens to the human beings or dog. You know, if you have two friends, and one is you know, big guy doing judo, and the other person is skinny girl, and if both have same ability, then the bigger guy looks kind of dumber, and the you know, thin, skinnier girl look smarter. It happens because we expect more to the bigger one, and we expect less to the smaller one. So my robot is quite small, so we expect less. Then, you know, if he does something like right now, he can answer several of my questions, and he can, you know, run and jump, and it's more than your expectation, I guess. But if he's as big as human being, we expect as good as human being, and as useful as human being, as intelligent as human being. But actually he's not. Then you feel, you know, oh, it's just dumb junk robot. So size is really important for human and robot. To show these things and to realize these you know, problems, I create robot. And actually, robot is a one-off concept robot. It's not for sale. It's the only one in the world. And but I believe it is necessary to create something and to show it to the public, to realize my, you know, vision. So I create, for example, robot by myself. I invent some technology, and I actually create it by myself, spending my money and time. And then I got offer from other companies, like some are venture companies, some are big companies like Toyota or Panasonic. Sometimes I got offer from foreign companies, like from the company from in the United States. And I let them use my idea for their products, or I design for them, let them use my patent, and that's how I run my business. And at the same time, I'm a researcher in the university. I'm a researching professor in the University of Tokyo, and also a visiting professor in Fukuyama University. And then mostly I'm doing research, and sometimes teach students, but mostly focusing on research. And I started my company in 2003, and actually this robot, Kuroino, is the first robot after I started my company. And this robot is chosen as one of the coolest inventions 2004 by Time magazine. And since then, I bring my robot to a lot of foreign countries, and work with a lot of people all over the world. And then I got a good reputation showing Kuroino, and then the toy company asked me to design their products, and then Manoi becomes was on the market. It is sold in Japan, and actually this is a kit, and the customer have to, you know, assemble by themselves. It's for a hobby. Unfortunately, it's not practical right now. And also, this is the latest one. We just started selling this robot in Japan. This is not named ROBO. And I have a video of a TV commercial. And this is a actual TV commercial, and so it is actually I work with an Italian company to make it as a product, and he can control a TV set, and of course a voice recognition, and he is not perfect as a home robot or interface between man and a machine, but somehow you can understand the idea of what the future robot will be. So I create this robot from scratch, and I started from the idea and doing research and design inside and outside, and actually I hand built a robot. And I'll show you how to build a robot, because some students might be interested in how I can create a robot. I'm using radio control motors, we call servo motors. I customize it. And also I use batteries for radio control models. And a small CPU board is sold for robot. A lot of products are sold in Japan, this kind of computer are sold in Japan. I actually do not use CAD. And instead of that, I hand draw on my notebook. The reason why I don't use CAD is because if I use CAD and I too much focusing on drawing in the computer, then the shape of the robot tend to be kind of boring shape, and also the design inside becomes also kind of kind of usual, normal, boring design, and also scale design. And that's why I hand draw the sketches for outer design, and also the inside I actually have the actual parts and design the image on the paper and also in my head. And that's how I create a robot. And to create the parts, I first carved with the mold, and I using a stove to make the plastic plate to make it soft, and put it on the wooden mold and suck the air by kind of vacuum cleaner or compressor, and then the plastic plate is shaped as well as at the same shape as a wooden mold. That's how I made the plastic parts. But it's not strong enough, so I put the carbon fiber parts together, stick them together, and make the parts. And that's how I create ROBO. And one of the biggest features of my robot is I use these parts as exoskeleton parts. Exoskeleton is means it looks like a skin, but it also means a bone, just like a crab or insect. There's no bone inside. So my robot has outer skin, but it's also construction parts. And the reason why I create that way is because if you have bone inside and create robot, and after that you put the outer skin on it, then outer skin might hit each other, and the outer skin increase the weight of the robot, and that causes the problem. Robot cannot move as good as it was without the skin. So that's why I, use exoskeleton style. And I have to create a lot of wooden molds to create a robot. And the car, three-dimensional shape are all carved by my hand. And as you know, car designing a car is a kind of similar process. they use clay to carve and make the shape of the aerodynamic shape by clay. And the same thing happened to robot. We cannot design everything by computer. We have to mix these kind of handwork together to create something sophisticated. The programming is done by this kind of computer software. So without using computer language, I can use drag some indicator to set the angle of each joint and making pose and connect them together, and that makes a robot motion. And since then, I create robots like that way, and in this 10 years, I have created more than 30 different robots. I'll show you some of my creations. This is a Gabi. It's for Japanese TV program, and it has the feature of him is master-slave control system. Gabi has exactly same shape controller. So it's like a twins. And when I grabbed the doll-shaped controller arm and pulled it up, and then the actual robot do the same pose. And that's how I control the robot for a TV program. And this is an animation character robot, Ghost in the Shell. It's like a four-legged robot for DVD promotion. And this is for RoboCop. It's the world's biggest robot competition. And more than 40 different countries, 200 teams participating in this event. And playing soccer football game. And these robots are autonomous. So they are quite smart, but actually you can see transparent head. It looks like no brain inside. But unfortunately, brain is in their body. The head part is a camera. It's a 360-degree camera, so they can see all direction in the same time. And this is a trophy sent by Louis Vuitton, and this is actual RoboCop soccer game held in Atlanta in the United States. So as I mentioned, robots are autonomous, so nobody controls it. So robots decide what to do by themselves. The bigger one, the black one, are from Germany, and this one, smaller, cooler, smarter ones are our robot. And the goalkeeper. And this year, we have 2 robots each. So, but you can see both German robots on the screen. That means nobody's taking the ball. So we won the title from 2004 to 2008, and they become world champion in RoboCop. And a couple of years ago, Japanese women soccer team with a world title. So now I'm waiting for male and men's soccer team with the world champion title, but it's quite far to to be number 1. Anyway, I also create a female type robot called FT. Until 2006, there was no female type bipedal robot. The reason is clear. It is harder to create a skinnier, thinner robot because robot have so many parts inside. A lot of motors. She has 23 motors and computer, batteries, and a lot of wire cables. The robot tend to get fat. And so that's why there was no slim female type robot. So I use a lot of small parts and customize them and design this robot. Also, I got advice from a professional fashion model to walk just like a female. And making pose. Another one. So until then, all the robots are muscular male robot. Then people tend to think, the robot can carry heavy luggage, or two robots can fight each other in doing boxing or something. So people think that way. But after I showed this robot, people a little bit change their mind. And this robot is introduced in fashion magazine, Vogue. And also the picture on the right side is I was with Miss Universe in the event in New York. And it's such lucky experience for me to to meet world's most beautiful girl, beautiful lady by creating robot. So how lucky I was. Anyway, also I create this robot in Volta. Probably you might see the picture on your brochure you have right now. This robot is designed to promote Panasonic batteries, to prove the power of the battery, to prove the long life of the battery. And I designed this character and also create after robot and go to Grand Canyon in the United States. It's such steep cliff. The height is 530 meters. We went down to the bottom by helicopter and turn on the switch over here. And there's a small robot go up little by little. But it's such a tough, nature. I mean, there are a lot of cactus there, and also weather is so unstable. Actually, there are rattlesnake, and it was really a tough challenge. But after 6 hours and 46 minutes, he went up to the top. And today, I have this robot also, so I'll show you this Volta robot from my bag. And this is the Volta. You see, he has 2 batteries on his back. And the rope I have now is a climbing rope. It's so strong. Even I can climb up this rope. So I'll do the demo first on the edge of the stage, and then I'll do again in front of the camera. So he goes like this, little by little. And if we put some kind of wheels on it, he can go up to the top of the cliff like less than 10 minutes. So it's not rational to move and climb up like this, but it's necessary because people feel some kind of sympathy. Oh, robot is working hard, and people feel sympathy, and then people remember his the robot's shape and the color and also name, and that works a lot for battery promotion. And so after watching him, people people choose this battery, Evolta battery. I'll do it again in front of the camera. Yeah, this is how he go up little by little. Thank you very much. So after he went up to the top, we realized he still has some battery power. So that's why we decided to do even longer challenge. And next year we went to Le Mans in French circuit for World Guinness Challenge. And this time we went to the racing circuit in France, and we occupied this huge racing circuit just for small robot. So every time the challenge is so expensive, and I'm the only one responsible for robot, and also that he is the one it's quite small. This time he has infrared sensor, and he find a motorbike in front of him and try to follow him, and that's how he can circle the racing circuit. And without changing batteries, the two AA batteries, he kept running even at night. Well, actually, I was sleeping at the moment because I was too sleepy and I was too tired to create him. But he kept running in the morning, and I just woke up and waited for the moment, 24 hours. I was really happy at the moment, and we celebrate the goal by champagne, and so that's that. And after 24 hours, the battery is almost empty. So I think there was no more tougher challenge. But unfortunately, Panasonic decided to use rechargeable batteries. That means you can recharge it and it becomes full. And using rechargeable battery, we did triathlon in Hawaii, Big Island. And there's an Ironman triathlon, it's such a tough race for human beings. We do the same thing in the actual the same course in Hawaii Island. And the first one is swimming robot, and swimming in the ocean. He's swimming, but he actually needs a float to have the floater. And this is the bicycle one, sometimes fall down. This is the running one. And they spend almost a week to run triathlon Ironman course. And that's last year's challenge. And well, you might think, what's next? I mean, what's for this year? But unfortunately, Panasonic is not doing well this year, so it is postponed. And I hope next year we'll have the even greater challenge. And also, I'm working on another huge, challenging project. It's a robot for space. Now I'm working with Toyota and the car company to create this robot, small humanoid robot, to send to the International Space Station. And he's gonna stay about a couple of years and talk to having communication with an astronaut, and to help doing, for example, to do some tasks, to help astronauts to do some kind of task or experiments. And also he can be a companion for astronauts and having daily conversation. And so it's a partly experiment and to prove the future possibility of this kind of communication whole robot. And also it's going to be a big challenge for human being, or to have such humanoid robot in space. And after he come back to the Earth, then he's going to be the first robot go outer space and then come back to the Earth. So that's a kind of historical challenge. And there are a lot of interesting challenge and interesting robot is developing in Japan. The reason is in Japan there are a lot of technologies going on, and also we have a culture. I mean, the manga, animation, cartoon, these things related to Japanese robotics field. So robots have both, technology and these kind of pop culture things. Japanese people are Japanese people have a kind of positive image about the robot. The reason is because of the pop culture. And our robot in science fiction or manga, animation, they are in between machine and human. And compared to, for example, the American robot in Hollywood, most of robots are designed 99% human being or 99% machine. And sometimes that's a reason why the most of Hollywood movie robots are such scary. And instead of that, Japanese robots are smart enough to be our friend, but not too smart to take over the world. So that's the important thing by our pop culture. And because Japanese animations are getting popular and popular, then a lot of people, even in foreign country, they change their image towards a robot. And so, as I mentioned in this lecture, well, I designed and create humanoid robot, and I realized the humanity is getting more and more important. The humanity is a word actually Steve Jobs used in his speech, and especially for the robot, humanity is so important. And to design robots which can communicate with us and live with us, we have to know about ourselves. And we have to, and according to the knowledge about ourselves, we can design inside, outside, motion, communication, these kind of designs. And by using robot, we have to also design the lifestyle with robot. And to do that, we have to be creative, and we have to feel fun through the inventing of new technology. I mean, most of industries or inventions recently, like for example, Facebook or Twitter or even YouTube, these IT technology, IT industries are based on fun. I mean, some geeky, crazy American MIT students or Stanford students, they invent some kind of strange things and they show off on the internet, and a lot of people, watch it on the internet, and then somebody, pay money as a funding and they start up their own company, but still they don't have any usage, or they don't have the business model how to get money, but it's fun, and that's why people support that. And after a lot of people use their products or their service, and then finally usage come up. Like Facebook can be matching people for business or marriage sometimes, or Twitter to share the information. Like for example, the big earthquake in Japan, the Twitter is used for sharing the information, or YouTube for showing your info for your works, artworks, or showing your sharing your daily life with your friends. So what I'm trying to say is this kind of fun can be new industry, and I hope you treat robot as a fun thing, and adding some humanity on it, then it can be really great. So robotics can be a great industry all over the world. And this is my last page, and I believe that kind of future, I mean, living with small humanoid robot can be realized in 15 years. In 15 years, you will have your own small humanoid robot in your pocket and talk with you. And then at that time, when it is realized, all the industries, all the researching fields, and even your daily life, all connect, all somehow related to robot. So what I want to ask you is, please connect your profession and the robot and create something new. And it is necessary for us to realize future life living with robot. So please, keep some kind of, something in your mind about robot, and and then someday the image of my robot or image of something you hear today can be connected to your profession and become new invention and a new innovation. Thank you very much.
Salam alaikum. Thank you, Professor Tomotaka. Any question, Dr. Amanal? Dr. Amanal? Okay, maybe we start questions from here. Yeah, there is a question.
Dr. Muhammad?
Yes, please.
Yes.
Any question?
Assalamu alaikum. Thank you very much for this excellent presentation today. I have a question to Professor there. Is about the idea that he was supporting throughout his presentation is about designing and small, cute robot. I know this idea was supported by the way that small robots are easy to design as well as to train, I think, in terms of autonomous. My question is that why, what are the main objectives of designing such small robots? And if we look at the other side, for example, Asimo is, kind of same size as a human being, if you look at it, and has achieved great development since the year 2001. So, to be more precise, what's the idea behind or focusing mainly on small robots rather than bigger size, similar to a human being? Thank you.
So, they are, Asimo, Honda is trying to build this human-sized robot. And, so they're trying to create something which can communicate with us, and at the same time, which can do actual, physical tasks. But actually, so I believe Asimo is the best robot, and then Asimo is is a kind of the number one in the world, but still it's not on the market and it's not sold as a product because that's a reason, that's a problem of the size. It's almost impossible to make it 100% safe, and it's almost impossible to make him as good as human being. So in my opinion, we can separate communication part and the physical task part. And the communication, for communication, the robot can be small, and for physical tasks, we can have like a wheel moving, like a Roomba, the vacuum cleaning robot, or other electric appliances, which can improve to be such a kind of a function, practical robot. So that's a difference of my idea and their idea.
Excuse me, I have a question.
First, I'm Sambakul from Kingdom Schools, and I want to ask you a question. When did you start thinking about that business?
When I start thinking about it, robot as a business. It's my kind of hobby, and you know, a lot of you know, founder of the companies like you know, Steve Jobs or Bill Gates and you know, or Hewlett Packard, and you know, these companies are not recently thinking about the business. They are just geek. They love computer, and one day they notice it can be a business, and one day all the other people realize, oh, computer is useful, and I believe the same thing is just happening. You know, I love robot, and that's why I started my company, and that's why I started building robot. But now a lot of people realize the potential of the robot, and a lot of people start robot business, and a lot of monies and talents are coming into this field, and so well, luckily it becomes a business, but I never think about a business, you know.
Okay, what's your goal about that working on robots, building robots?
Well, my goal is everybody have their own robot, and they use in their daily life, just like personal computer or smartphone.
Yes, but it's not for sold. It's not for buying at the shops. Why you say everybody have a robot in his home, but why you do not make another ones so some people will buy it at the stores?
So in the future, in 15 years, and also I need your help.
You have first the customer.
Yeah. Or customer, or you can help my research.
Professor Tomotaka,
Thank you.
we have a question here from Abdullah. Abdullah is 9 years old and is asking you, can you buy those robots?
Please, yes.
Abdullah is asking you if we can buy your robots or not.
Well, so now one of my robot is just start selling, and well, actually I have several products, but they're not as good as the latest one. The latest one is well, it's still not practical, but you can somehow, you know, feel the you know, feel the vision of future robot. So the robot can communicate with you by. Right now it's only in Japanese, but in the near future it's going to be like English or Spanish or Italian. And also they can control some your TV set, other machines, but not internet yet. But you know, in the near future it's going to communicate with the internet. And so, well, it's moving so fast, and well, in probably a few years. You might have your own robot.
Thank you. We have another question, if possible.
Just maybe we'll take 2 questions here, and we'll go back to you. Please. Yes, no.
Yeah, I have a question about machine learning. Human robots, right? Of course, right? We are impressed, right, with the articulation, joints, right, and jumping and keeping a balance and not falling down, right, and walking and running. Very impressive. But I believe, right, that the most impressive thing about human beings are learning. We really, right, have the capability, right, of developing, right, and not only memorizing, right, new things, but also, right, develop behaviors, right, that we never actually, right, learned by recording. We don't record. We reason about things, and then, right, we do things that really, right, are impressive, we as human. And do you have any of these machine learning component not programmed in, right, as wired in programming?
Well, there's no learning by robot because Well, actually, there are a lot of talented people about artificial intelligence or learning programs. These kind of researchers or engineer in computer science field, well, right now, most of talented people in this, I don't know, 20 or 30 years, most of talented people go to computer field, and because computer was not as good as engineering, and but the computer improved so fast, and now engineering is kind of not as good as computer. And what I'm trying to do is push up the engineering and connect to the combine with the computer genius people, and then it can be our companion. So the answer of his question is, I'm not doing learning robot or learning program itself, but once I create a good platform and somebody can combine, or probably I can combine their invention and mine, and they can be have more better robot.
Okay. Any other questions?
Yes, we have a question here.
Dr. Mana, just we will take one question here, then we are back to it.
Okay. サラムアレイクム。こんばんは。私の名前はマルです。はじめまして。私は日本語が少し話せます。よろしくお願いします。でも、I have a question regarding the future. Now, do you think that robots might involve emotions and they can feel feelings in emotion like cry, sadness, jealousy? Thank you. どうもありがとうございます。
Well, actually, emotion can be some part of design. Our emotion is expressed by kind of slight motion or slight expression. And to feel the opponent's emotion is, watching and reading opponent's emotion by, for example, opponent's voice, opponent's slight movement of the body, or these kind of things. If robot can do expression in this small expression to express the emotion, and then also robot can feel the opponent's emotion, then that means almost the robot have emotion. So robot don't have to have real emotion, or robot, or it might be impossible to have emotion, but robot can be designed as if they have emotion, and I think it's enough to communicate with us.
Dr. Amina?
Okay, we have a question.
I want to ask about the character design process. You mentioned that you prefer to sketch rather than using CAD to create 3D models. Can you please tell us more about this part?
Well, first of all, I got a lot of influence from Japanese animation, like Astro Boy and Sanshiro. I heard it's famous in this country. I got a lot of inspiration from this kind of manga animation characters. And then I draw sketches and on my notebook, and also in the same time I have to design inside. Actually, that's the most difficult part about robot. And the outer shape and the inside mechanism realize both in the same time. I have to think both in the same time. And to put parts, I have to change this outer shape, but if I change the shape here, it becomes uglier, then I I have to find a smaller motor. This kind of friction is happening, in whole process. So I believe that I'm good at, working on that problem and find the best solution to have both character and inside, internal design. So that's how I, design, character and also design inside.
I have one question, if you want one question. In fact, we already discussed about this just 1 hour before the lecture, about the DARPA project and challenges. In fact, like you said, most of the, I think the hardware, the devices, there is a lot of producers who make products. What are the challenges is the autonomous. So to make a robot which is autonomous means, for instance, Evota can climb any kind of rock, any kind of, let's say, mountain if you want. So the autonomy is mainly software. So it's mainly techniques, machine learning, artificial intelligence, and so on. So this is why the challenges focus mainly on this side more than the hardware platform. So what do you think? How you can see this? Could in 10, 15 years from now, you said we may have individual robots, but this individual could solve these issues of autonomy, fully autonomy, not predefined on specific tasks, something like that?
Well, actually, researchers tend to think autonomy is important for robot, but I believe remote control is also a good way to keep robot intelligent. I mean, a lot of, I believe the hybrid of remote control and autonomous will be the best solution. For example, during the conversation with robot, talking about stupid thing, then robot can react autonomously. But if I have, like, for example, heart disease or some kind of serious situation, then robots should be controlled by somebody from the operating center or somewhere, and somebody asks what's going on with my body, and then the guy called ambulance or something. I mean, so it can be hybrid, and also the important thing is between this remote control and the boundary of the remote control and the autonomous should be invisible. It's smoothly connected, then if the the AI getting better, then AI percentage is getting bigger, and remote control part is less. But somehow hybrid is the best.
Good evening. Thank you for the lecture. It was a very nice lecture, a different type of lecture. My name is Tarek Al-Sanagawi. I'm the Deputy Director of the Research Center at PSU. And we are actually working since a couple of years in a joint project with postgraduate students here and in Germany. But something similar to that, but we are working on smart clothes, smartware based on fiber optic sensors. So, and basically it is an application for the health monitoring systems. so bedridden patients can wear it, or athletes, or whatever. So the idea came now to me, why not using such small robots as a portable nurse, for example, to have it at home with sick people, and the smart clothes sends signals of life signs like breathing, respiration, heartbeat, temperature, whatever, or motion, and the robot controls something like that, or recognizes if something is wrong, and talks to the patient, or sends information to the doctor, a kind of monitoring procedure. Have you worked on anything similar like this before?
Well, never. And the reason is, I totally agree and on your point, and I believe that kind of a robot will be realized in future. But after, the robot for everybody and the robot is used by everybody, and then go to these kind of specific robot. I mean, for example, the car. Everybody use car as for transportation, and then become some specific variations like ambulance or fire engines. Well, we cannot go straight to the fire engines before the car is invented. So, I mean, the biggest market and the more common usage is first, and then next go to several specific niche usage. And medical robot, like you mentioned, like for nursing or for to monitor the health, will be I think will be the next step.
Thank you, Professor Tomotaka. A couple of questions actually. Earlier have been chatting actually. You said that actually robots in the future will be so small that you can carry them in your pocket. Will you still call them robots in that case, or it will be something else? I mean, this is the first question. Second question, speech recognition and speech communications with these robots. Is there any breakthrough? We have seen so many attempts from mobile platforms, and those are still very sketchy. They still use Markov-chains. Is there any breakthrough in voice communication with these robots? And a third question, sorry, I have so many questions. I will remind you. Networking, I mean, is it possible to create a community of these small robots, for example, to achieve a common goal? Is this something in your plan or your mind? I mean, a community of robots, a collection of robots that communicate and collaborate to achieve a common goal. Corporate robots, okay.
Well, so I cannot remember.
The first one is that small robots.
Small robots.
Will you still call it a robot if you can carry it in your pocket? Or?
Well, I think so. It is still called as a robot. And, I believe, we somehow dream small, smart something with us. I mean, like Tinkerbell in Peter Pan, or the Jimmy the Cricket in Pinocchio. Or some Japanese the Ghibli, Hayao Miyazaki animation. They all have small animal or small some kind of fairy or something on your shoulder or head somewhere, and they are quite small and they have a lot of knowledge and they support main character. So it's kind of our instinct to have small something, and I believe it is still called as a robot.
We suggest pourquoi The website suggests to call it.
Yeah, please go ahead. Just another question. That is, yeah. Sorry, Dr. Manel, just two more
It's
questions.
not a question, it's only a comment. We suggest pocket, like pockets. A name, as a name for the small robot. Pocket.
What?
Like a pocket robot.
Yeah.
Well, you know, it's a difficult. It's a somehow toy. You know, a Roomba, the home cleaning, vacuum cleaner robot. They start their first product as a toy. It was sold in Toys R Us as a toy shop. And but now Roomba is not toy anymore. So right now the robot is not as good as electric appliances, but it's it's just toy level. But pretty soon it's not toy anymore. Well, the speech recognition. Well, so breakthrough. The gatherings, people's questions, and the iPhone cannot answer well. Then they write better answer by human being, and adding more and more by human hands, human power, like just like Wikipedia. It's another possible way if we have this kind of network, internet, or something like that. So well, there's a lot of good voice recognition technology and IT as an IP service, so we can use it for mobile. Well, I have no idea.
Just one question from we'll come back to. Please,
Hello, sir. This is Muhammad Gawad here in the POP Preparatory. So I have a couple of questions. The first
just
question.
two.
Okay, two questions.
Please.
So the first one, how old are you when you first started your robot? When you first created your first robot? How old are you when you first created your robot, your first robot?
Well, I create my first robot I'm not sure, like 5 or 6 years old, using paper and just children's, hobby.
Okay. Another question. Voice recognition have problems with iPhone and other devices. Do you feel the same problem in robots during creating the robot? Voice recognition.
Voice recognition.
Well, I believe voice recognition is getting better and better, and also the having body and having presence of the real robot can help somehow. For example, like me, I'm not native speaker of the English. It is harder for me to talk to somebody on the phone or telephone. But if I can meet somebody directly, then I can understand through the expression or the face. So having body with voice recognition, it's one of the solutions.
Thank you. Just we will have a couple of questions, and of course you can write your questions. The embassy will take them later on, so Professor Tomotaka can answer later on. Go ahead, Dr.
That's a very good question. Now let's assume that if you would like to introduce more intelligence, so in this case maybe the small microcontroller will not be sufficient. So you will be constrained in terms of how small the design could be. Maybe in this case you will need to increase your the size of the robot, right? Because now I think you need only small memory because you have specified functions to be executed, like speech recognition or something they are static. So
actually, it's not true because right now a robot carry all his knowledge, all his intelligence in his body, but it's not going to happen anymore because the robot's going to connect it to internet and all his knowledge, all his intelligence on clouds somewhere. Okay. So he doesn't have to carry everything. So that means he can be smaller and smaller.
Okay. Yes.
Excuse me, we have a question here.
Yes, please.
私はです、暗号研究者です。よろしくお願いします。I am an electronic hobbyist myself, and I have four questions. The first is, what's the size of the servo motors usually in these small robots? Like, is 9 grams big? The second question is, what kind of a book would you recommend on robotic kinetics? The third question is, what is a good vendor for these parts? Like you mentioned, these parts are from Japan. Like what shop would you recommend in Japan? The fourth question is, as comparing your robot with the NAO robot, I think it's made in the United States, what's your opinion over that? And the use of Raspberry Pi and other like Arduino inside robots, what is your opinion over that? Arigatou gozaimasu.
Well, I'm starting from the fourth question, the NAO. It's actually French robot. And, well, I met them several times, and well, it's a good robot, but I believe their robot is still too big. You know, if it falls down, robot got damaged, your table might got dent, and it's still too big. And they're thinking of making the robot bigger and bigger, and I don't agree with their idea. That's the difference. And the shop, Japanese robot shop. There's a lot of Japanese robot shop, and especially in Akihabara, it's famous for electric plants stores and also manga animation with otaku geeky culture. There are, I believe, there's more than 5 different robot shops, and well, they do have internet shopping, but I'm not sure if they can, send parts to the country.
友達、日本に
So, well, I sometimes work as a VSON, the company who create my programming software tool and also the computer board. And they have a shop in Akihabara.
Can you repeat the name, please?
VStone.
VStone?
Yeah, VStone.
VStone.
V as a victory and stone as a stone, a rock stone.
Thank you. I think the very excellent presentation of Professor Tomotaka raised a lot of questions. This is why you have the paper next to you. You can write the questions. We will make sure that whenever Professor Tomotaka can answer them later on. Of course, you can contact Professor Tomotaka directly through his email and to have also a lot of, and we hope to have you again here at Princeton University. Yeah.